Hello, everyone. So we're here representing the group that did the workshop in hydrogeophysics last week. So we want to show you what we did for 3 days. So we took seismic acquisition and also ERT acquisition by the beach. So here you can see the seismic line. It was parallel to the shore, and the ERT line was perpendicular to it. So starting with the seismics method, we did a seismic refraction, so just a bit of a theory about it. Seismic refraction is based on the fact that a wave is going to propagate from a source and it's going to hit an interface in a critical angle. And then the wave is just going to propagate through the interface with the velocity of the second layer that has to be more quicker or has to have a higher velocity than the previous layer. So when the wave propagates like this, we get the head waves that go back, and we recorded with geophones that look like this. And we used one component geophone, so they would only measure the movement in the vertical position. And the source is someone hitting with a hammer on a plate, and we had a line of 12 geophones equally spaced by 50 centimeters, and we shot at every geophone position. And yeah, now Charlotte continues.
So here are the results we can have. We picked up each first arrival time, like this line, and then we generated a prior model with a horizontal layer velocity, and we generated with an inversion to match the data a new model. And we can also look at the wave passes, which can help to improve the first model. Yeah. Next, ERT.
Thanks. So now I'm going to talk about ERT. So here we are not interested in seismic waves anymore, but in resistivity, so it's not velocities. And we have different ways to measure this. There is a Wiener disposition and the dipole-dipole. So the Wiener disposition is you have electrodes A and B where you inject current and you're measuring the tension between M and N. So you can have the resistivity of this part. And when you do this, after you change the distance between the different electrodes, so you have a line here, and you measure for 1, 4, and 2, 3, and then you increase the distance, so this kind of stream, like that. So as you increase the distance between the electrodes, you go deeper in the ground, and you catch the resistivity of the whole mass. So it's you integrate all the resistivity. So you do this for different distances and different positions, and you obtain points at different locations. And you have also the dipole-dipole that is almost the same thing, but you inject a current in AB and Mn with a distance that is differently done. Okay. So here's a kind of thing that we did. We put the electrodes in the sand, so you have to be careful so that the electrodes are well in the ground, and you do not have to touch the electrode during the guy that helps you put the current in the ground.
So let's have a look now about the results. So this one is with the method of Wiener. So what we can see in this result, it's mainly that there is lower resistivity towards the sea. So on this side, that's something that we were expected, because there is salt water next to the sea, and so there is lower resistivity. So that's the result with the method of dipole-dipole. It's a bit different, but the main features are the same. So lower resistivity towards the sea. So to conclude about what we did in geophysics. That's nice. So we did two kind of measurements, so seismic refraction and ERT. So we were measuring two different geophysical properties of the subsurface, and both of these methods are very powerful to investigate shallow subsurface. And so we made a very huge discovery. Apparently, there is salt water next to the sea. So we are planning to publish that as soon as possible, of course. But even more important, we had a very nice time on the beach with Damien and Silver. A lot of fun.
For the parallel with the seismic, I would say, so we want to map like the water table usually, and like it makes more sense to map it like that because it's gonna be like at the same Z position if you're like parallel to the shore. And with ERT, it was perpendicular because we wanted to see how the water is intruding, like more outside of the sea, and see that change of salinity closer to the sea than to the villa.
Another reason is also that when you do seismic, you want to avoid some noise and the waves. It's kind of wave propagating, so you don't want to put your geophones too close to the sea.
For your discovery of the desalted, could you go have another discovery that the other? Do you see the fresh water also? So do you see water that would not be salted?
See, like the water table, you mean?
Yeah. Do you see a boundary between fresh water and seawater?
I think here with this result, we cannot see that, or I'm not seeing it, at least.
Where is the seawater interface here?
I'm not sure we can map the interface, but we see that there is like lower resistivity, so it's depth to the salt water is becoming shorter and shorter towards the sea. But
So I would just basically say that yeah, the sea is towards that direction and it's coming here where you have like these really low resistivities, and yeah, over here you just like meet the bedrock, and that's where you would have your limit between the salt water and I wouldn't know about the fresh water. I don't know.
Would assume that what is not blue is fresh water.
Sorry?
Would you assume that what is not blue, what is red is fresh water?
yeah, but also there is the bedrock there, and there is the sun, so there is a both effect of geology and.
But if you had bedrock in salt water, would it be red or blue?
Let's say blue.
Purple.
Are you on the bedrock on the right, or are you on?
That's on the bedrock.
My God.
Did the refraction study make sense? In that
Let's
there
go
should be
back.
some depth roughly uniform for the water table.
Yeah, well, the refraction result is based on our picking, so yeah, it might not be too exact. And I don't know about the depth. I don't know if the guys dig a hole. I don't know if some of because I think none of us actually did the seismic on the beach. We did it behind the villa, so it would be good. You did, yeah. Did you dig the hole? Yeah, to see like where was the water when.
But we have not put the results in.
Okay.
Yeah,
But it should be about 1.6 kilometers per second.
Yeah, of course. If it's fully saturated, yeah, it's gonna be faster.
1 meter below the surface.
Yeah.
yeah, but in depth it's not that precise because our line wasn't long enough. So we cannot take into account really depth. The 2.52 kilometers per second. No.
No.
Do you also expect to see a signature of salty water in seismic data? Or only information?
Only with the RT, I would say, because yeah, I mean, you cannot pick the density change of salt water and fresh water with the seismic wave propagation. I think that's asking for too much, but yeah, especially with this resolution.